What's up, YouTube? Hello, guys, and welcome back to Bite Size Security. I'm your host, Jimmy, and today I am bringing you the first challenge video of this new series on blockchain security and smart contract security. I'm not going to beat around the bush too long. Let's get right into it. I have a few housekeeping things that you're going to need for this series. And so the very first I'm going to start with that is a solid understanding of the Solidity programming language. This is very important because one thing you must understand is that smart contract security is a lot of code review. It just is what it is. And so you're going to have to learn the basics of Solidity and even go a bit further beyond that in learning Solidity programming language. There are different languages that smart contracts are written in. Rust is slowly but surely taking up. There is also Viper, which is more like a Python-based smart contract language, but then there's some others. There's Move, and then there's some others, but the Move is also Rust-based. So I would say there's Rust-based languages, and then there's Solidity and Viper. We're going to do Solidity. And so how can you learn Solidity? I'm going to give you 3 main resources. Of course, they're going to be in the description. The first one would be Crypto Zombies. And Crypto Zombies is a pretty fun interactive way of learning. It's a game. You're going to build the game, and while you're building it, you're learning new concepts and applying them to this NFT kind of based game. It's really fun. That is how I learned a couple of years ago when I started doing Solidity development, because at the time I already wanted to do blockchain security and I started with this. Then after this, there is another course that is completely free and it's absolutely incredible. On YouTube, you have a 16-hour course that teaches everything that is being shown in this lectures here. Of course, 16 hours, you're not going to watch it in one go, but that's just to say that there is ample resources to learn Solidity. And it starts with the beginner course, and then it teaches you the Foundry fundamentals, and then after there's more advanced courses as well. And then the final thing is going to be Rare Skills, and Rare Skills is Learn Solidity, this one. And here you will have these beginner concepts, same as with Crypto Zombies. You have the beginner Solidity tutorial. And then as you go through with it, then you'll have to build some projects, because it's really important that you then apply your new knowledge. And then you have intermediate topics, the different Ethereum requests for comment, and the EIPs. And they are essentially standards and additions to the standards. If someone requests or suggests a new change to the Ethereum protocol, they submit a EIP, my bad, and then if it gets implemented, then it becomes an ERC, if that's how I understood it correctly. Oh, don't quote me on that though, because I think there's some minor details there that might be wrong. But anyway, then there's some more advanced concepts that come here, DeFi primitives, because after a certain while, you'll just have some building blocks of DeFi that come back over and over and over again. You will have this with, for example, Flashloan implementations, or like here, Master Chef or Synthetics, which are staking algorithms, or yeah, so here you can see Flashloans, and then you'll have price oracles, and they have a certain implementation, and you will just see these things come back over and over again. Another one is obviously Uniswap, and then there is also upgradability and stuff like that come back over and over in this smart contract. And if you really have a grasp of how they're implemented, you'll be able to find bugs more efficiently. But yeah, Rare Skills is also incredible. But then there's one more, and this is a fully fledged course, but it takes you not from zero to hero, but from where you'll be after you've learned the basics to a more intermediate level. And that is a course by a guy called Johnny Time, and it's an excellent course. Of course, everything that I'm quoting on now, I'm going to put in the description later, of course, so you're going to be able to find everything there. But I'm not going to introduce the course. I'm going to let my friend Johnny Time take it from here and explain to you his course. And again, it's all going to be in the description. Take it away, Johnny.
This is the website. It has different sections about a certificate that you're gonna receive upon completion, the welcome email. You're gonna receive a personal welcome email where you're gonna receive the access to the course. All the chapters are gonna be there. All the recorded videos, the exercises recordings, the walkthroughs grant you access to this awesome organization. With on enrolling in the course, you get a golden ticket and exclusive access to the best Web3 security community out there. Hello guys, it's Johnny Time. If you are a beginner in your Web3 security journey, or maybe you're looking to enhance your skills, to gain more knowledge, to get more practical experience, maybe you're looking to secure your first junior smart contract auditor position, or maybe you just want to join an awesome community of like-minded professionals. I've got some awesome news for you. You came to the right place. You probably heard about a smart contract hacking course which created a crazy buzz in the community recently. And if you did, in this video today, I'm gonna make all your question marks disappear and walk you through the experience from the moment that you enroll in the smart contract hacking course. So without further ado, let's get started. So you probably saw the website smartcontractshacking.com. If not, I will put a link in the description below. And this is the website. It has different sections. These are some sections that show the opportunities in this space, some information about the course, about a certificate that you're gonna receive upon completion of the course and the final exam, the community, but we'll get to that later. Here you can see in this section all the experts, all the teachers in the course. Obviously, most of the lectures will be by me, but we also have guest lectures from the best professionals in the space, which we collaborated with to give you the best learning experience and so you can gain the most amount of value from this course. We have Trust, we have Pashov, Owen, and Bytes, and more to come in the future. Spoiler alert. And this is the course outline. You can see that the syllabus is packed with valuable content. Everything is covered from the beginning to the end. If it's EVM, dev tools, exercises, guidelines, we're gonna go through some token crash course and DeFi crash course so you can really master those most used standards and protocols. And we're gonna cover so many attack vectors. And also the guest lectures are gonna be awesome and add more value on top of the course syllabus. Now, if you want to get all that and join the course, we can offer you a special limited time discount where you can use in the link in the description below. This is limited time discount, so make sure to use the link in the description below because the pricing of the course, the value in this course is tremendous. So if you want to lock your golden ticket to the community, the lectures, the exercises, and all these awesome things that we covered in this video, use the link in the description to get your $50 discounts. Thank you so much for watching this video and for securing the Web3 space. Bye-bye.
And that was it. Thanks for that. Obviously, I did that course, I did the exam. It was an absolutely incredible experience. I learned a ton. And having done the learning Solidity, then that course, you will be well on your way to first of all, follow along on all of this, but then also do your own auditing and hopefully make some money doing that. Anyway, let's get into Unstoppable. So what you're going to do is go on Unstoppable, of course, and then see the contracts. This is going to redirect you to GitHub and you're going to clone this repository. So you're going to go here, clone the repository, and download it. Now I've done all of this already, so I hopefully won't have to explain how to clone a directory. But what you're going to have to do before anything is type forge install when you're in the folder, right? Because that's going to install all of the dependencies. And I've already done that because it does take a little while. And once you have done that, you can finally start with the coding. So let's go into the README. And one thing I didn't really precise in the last video is that smart contract security is a lot of code review, right? It's not as fun and eventful as Active Directory pen testing and going through the different layers of security in a system and all of that jazz that we used to do. I know, but I like it. I like it a lot because you really get to be part of the cutting edge of where finance is going, of where security is going, and I like that idea. But anyway, Unstoppable. There's a tokenized vault with 1 million DVT tokens deposited. It's offering Flashloans for free until the grace period ends. To catch any bugs before going 100% permissionless, the developers decided to run a live beta in testnet. There's a monitoring contract to check liveness of the Flashloan feature. Starting with 10 DVT tokens in balance, showed that it's possible to halt the vault. It must stop offering Flashloans. So what's being requested here is to cause a denial of service attack. So somehow you're going to be able to break the functions, right? And so let's just get into it. We have two contracts. One is called Unstoppable Monitor and the other one is Unstoppable Vault. Now we're going to look into the vault first. And let's first introduce the concept of a flash loan. Flash loans is something that was introduced with DeFi, decentralized finance. And it's essentially, remember when I said that there's no middleman in decentralized finance, so there's no bank. So everything that happens here in terms of providing liquidity, borrowing out money and lending money all happens by you, the user, from the world. So everyone else is providing liquidity. So here, you don't go to a bank to request a loan, you come to a smart contract and you have to abide by certain rules that are coded into the smart contract. And if you pass those rules, then you can borrow a certain amount of liquidity, an infinite amount of liquidity, as long as it's, of course, lower than what the vault has. But these are huge sums and you get to borrow it with a fee. Of course, that's how it makes money. And the only requirement is that within the end of the transaction, you perform whatever actions you want to do with the loan and pay it back by the end of the transaction. So Ethereum smart contracts are atomic. So if part of the transaction fails, everything fails. So you can have a lot of logic within a transaction, but at the end of the transaction, the entire loan needs to be paid back. This is unheard of in traditional finance, but in decentralized finance, this works. Now, there's various use cases for why you would need a flash loan. Maybe you can take advantage of an arbitrage opportunity. For example, in one exchange, a token is cheaper than in another one, so you will quickly buy it there in a huge quantity because you have a massive flash loan and then sell it somewhere else very quickly, and that would be arbitrage trading. And so there's tons of various use cases for flash loans, but just to quickly introduce how they work. Now, to the contract. So we have a vault and we import a couple of libraries first, and the vault is called Unstoppable, and we also import these interfaces, right? The Entity Guard owned ERC4626, Posable, and Flashlender, the Flashloan protocol. Then we have some state variables, some constants here, and some error messages in case something goes wrong. Then we have the constructor, the function that is performed once, first and once at the beginning of construction when the contract is being compiled. And then we have different functions here. Let's go to the main function with the main logic first. Let me just remove this. So The Flashloan function takes a couple of arguments. It takes a receiver, address, amount, and data, which is the logic for the callback later. I'll get into that in a second. Anyone can call the function because it's external and it returns true or false, right? Then it has some sanity checks, some validations that first, the amount that you borrow cannot be zero. And if it is, then it will revert with the message invalid amount. And the token has to be address asset, and if not, then it reverts and says unsupported currency. And I guess this means that you can only borrow a certain token that is within the assets of the vault where you're borrowing the liquidity from. And this is, of course, implementation from ERC 3156. Then it just assigns the total supply of the vault to balance before. So it defines a variable called balance before, and it runs the total asset function on it. The total asset function is the one here above, and that just looks at the balance of this vault compared to this asset. So it will run balance of on the asset and get the total amount of asset that's in the vault. And then it will do this comparison, right? And it will check that the balance before is equal then the total supply of that asset. And convert to shares is just an implementation from ERC 626, and it's just a way to translate a total supply of tokens into shares. So if you have a total supply and you have given some of the liquidity to that supply, well, then you get a certain part of shares of that total supply. And that's just the implementation of ERC 4626. Now, quick parentheses. What I like to do when I don't know how these implementations, these standards, ERC or standards, then I go on Google, right? Google is your friend here. And you will just type ERC and then just Google that. And often there is the Open Zeppelin docs, or Rare Skills will have a document on it. And I love Rare Skills, I really do. They explain things very well. And here you can just read through everything, get to know the standard, and really get to know whatever is the importance, the implementations, the functions that are implemented within each standard. So yeah, definitely always read up on those. What does it then do? It then sends the token to the receiver, and then it will execute a callback at the end of the function. And this callback is what I said. If you borrow money from a vault, the Flashloan from the vault, well, you have to implement within your contract, within your smart contract, a function that the vault will automatically call at the end to get its money back plus a fee, right? And if that one doesn't work, well, then the entire function doesn't work. That's the atomic nature of smart contracts that I was talking about before. So you have to implement this. And here it obviously checks this. So it will see that it will call on receiver smart contract, it will call the on Flashloan function, and that will then compare to the hash here. And if that is successful, then it will pass. If not, then it will revert and say that the callback failed. So here it will check that if it's not equal, then it will of course revert. But to check the validation is that it must be equal. And then it will just pull out the money back and the fee. So I kind of explained this function now, and you can see that I am not going to dwell too much on the Solidity knowledge. I'm just going to act as if we all know Solidity, because that's just easier to do. I don't really want to teach the entire Solidity coding language. Anyway, so how can we break this? So the only things that this function that we can control here and find a way to break them is seeing if we can break one of these if statements, right? So if it's 0, well, then it just reverts. That's nothing really that we can break. And then if it's not the token that's within the vault that we can borrow, then it also just reverts. But here there is a comparison being done, and it checks the total balance of the vault at a certain time and makes sure that it's equal to the total supply converted in shares. Well, what if so? And if that is not equal, then it will revert. So how can we make sure that it's not equal, right? Normally we would have, let's say, how can we add a few tokens to this contract so that this no longer becomes equal? Well, do we have some sort of deposit function? No, we don't. But what we can do is just send a token to this vault, and then it will revert, because this comparison will never be equal, and therefore it will always revert, and therefore no one else that tries to run Flashloan, the function, will be able to do it, because this comparison will always revert. So let's do exactly that. I guess this is already the challenge solved, and so let's do that. We go into the test files, and this is what I was saying. You're going to need Foundry, because Foundry is where you run your tests. How do you make sure that you have the solution coded in and that it's running on chain? Well, tests are there for that. You can just run certain functions that will simulate whatever logic you are implementing into your contract, and that will then test everything. So here we're just going to have to write a function within test unstoppable, and then make the run that, and if it passes, then we know that we have solved the challenge. And how does it do that? Well, with this modifier, check solved by player, we can go up and it will define this modifier where it will first run a prank to simulate that the player is running everything within that function. Then it will run everything that's in the function. So the prank will be first, then everything inside of the function will be run as that player. Then it will stop the prank, and then it will check if it's solved. And that's this implementation here. So what can we do? We said that we need to make sure that the balance between that the comparison between the total supply and the balance of the vault are not the same. So we need to make sure that it's not the same to break it. So how do we do that? First, we're going to define a variable to check that we want to read what the balance of first the user is and the vault. And I'm going to go a bit verbose here to make sure that everything is very clear. So normally you don't need to do that, you just need to do one thing, but I'm just going to be a bit more verbose. So I'm going to say balance player before, and I'm going to assign to this variable the I think it's token. Is it token? Yeah, token. So that's the DVT token. So token balance of, and then address of the player. So to see how much this player has, and I'm assigning that to the player. And then I'm going to do the same. Balance, but of the vault, not of the player. And here I'm going to say the vault, and I'm just going to check how much is in each. So I'm going to say console log, because this way we can just print something, and I'm going to say the current balance of the player is, sorry, there you go. And then here I'm going to say player before, and then I'm just going to copy that because it's essentially the same, and I'm going to say balance vault of the vault is, and of the vault I'm going to do, no, sorry. So here I'm going to divide it by 1 ether, because if you don't, then the number that's going to print is going to be 1 to the power of 18, because that's so Ethereum, when you look at the number of one Ethereum is 1 to the 18 way, and so you just need to divide it by 1 ether to make it 10, for example. It will make sense in a second. And then I'm going to do what's going to break this contract, which is just send one random number just one way or 1 ether to the vault, because it doesn't expect that. So I'm going to say token transfer, and then I'm going to say to the address of the vault. I'm going to send that ether to the address of the vault. I'm going to send it, let's say, 1 way to demonstrate again what I was just saying. Normally I don't like magic numbers. This is something you will learn. Magic numbers are never good. It's better to just define it. So I can just say uint amount to break, or just break amounts. I don't know. Amount to send. To send equals 1, and then here I will not say 1, but I will say amount to send. This is cleaner code hygiene. And then what I can then do is copy this again, say the new, and here I'll say after, and here I'll say after as well. And this should be it. It's very verbose, but all we actually needed was this, and that should run. So if I say forge test --mc, and then the name of the contract, or just mt, I believe, and then vv to make it more verbose, then I should run just this function. It will first compile and it will pass. So first it will say that the player has 10 DVT tokens. Then it will say that the balance of the vault is 1000 or something like that. And then the new balance of the player is 9, but it's actually not 9. It's 9.999999999, because here I said divided by 1 ether, which you will see now. I sent 1 way. So this is not 1 ether, but 1 way. If I said here this, then you will see that it will be just 9. There you go. So that's how Ethereum kind of works in terms of numbering, right? But let me just go back to 1. And then it will say that the new balance of the vault is 1, 1. Sorry, this is now when it's corrected. There you go. It will then check what the new balance is, and so clearly the balance of the vault is now +1, and that will make sure that the comparison breaks. And how do we know that? Well, because the test passes. Now we have solved the challenge, because the modifier here at the end runs is solved, and if is solved runs, then it will pass everything. But I want to show you one more thing, and that is if you increase the verbosity, then you will see exactly what happens on chain. And here you will be able to see what exactly happens within the function. So it will emit Flashloan status. So where are we? Here, it will call Flashloan, right? And it will give it the arguments. So let me show you. So when you call Flashloan, you take a receiver, a token, address, an amount, and callback data. So here you will have that. So you'll have the receiver, the token address, the amount, and a callback data, which here is empty. Then it will obviously it will return bool, but that comes at the end, and it will first do the first comparison. So if the amount is 0, that obviously passes. And then if it's a token that the vault has, that also passes. But then it will do this comparison, and it will check the balance of the total supply and the balance of the vault, the token. And if they are not the same, so the balance before, it will check the balance before and the total supply converted in shares. And if they are not the same, then it will revert with invalid balance. And that is exactly what happens here, because the vault is this and token supply is that -1. And therefore it will then revert and say invalid balance. And then we will say emit Flashloan status, which is, that comes from, the emit Flashloan status comes from, let's see, I think that comes from the monitoring. Yeah, emit Flashloan status. So here it checks the health of the Flashloan, and it will first run it. It will try to run the function in the vault. So the vault contract, it will run Flashloan, and it will check if everything works well. And if it works, then it will say Flashloan status true, and if it doesn't, then it will say something bad happens. That's just a comment, and it will emit Flashloan status false, which is what it did here. And then the goal of the challenge was to make sure that the contract is paused, and we did that. So the vault was unstoppable. I don't think so. Anyway, and that was it. I know I kind of sped through this, but I don't want to make these videos too long because the challenge wasn't that difficult. But yeah, it's the first challenge. The next ones are going to be considerably harder. And yeah, I hope you enjoyed this. Again, if you want to follow along in these challenges, make sure you know some Solidity and get up to speed. And then I'm sure we're going to have a lot of fun with this series. This has been super fun. I'm very much enjoying smart contract security. I hope you will follow me along on this journey, and there's nothing more to say. Thank you guys for watching. Leave a like if you liked it. Please subscribe if you want to follow along on this series. And that's it. As always, this has been Jimmy, and I'm out. Peace.